Okay, so today we are going to review some of the subset notes and then we are going to move on to complement notes. Okay, so we're going to start off with some true false that were in our first note set. So we are given three sets, set A, set B, and set C. And the first question we're asked is B a subset of A? Meaning, is every element in B also in A? So what we do is we check, is 2 in A? Yes. Is 4 in A? Yep. Is 8 in A? Yes. And is 10 in A? Yes. So therefore that is a true statement. The next one we look at is C a subset of B? So we have the elements 4, 10, and 12, and we're checking to see if those are all in B. Well, 4 is in B, 10 is in B, but we don't see 12. Since we don't see 12, that is false. Okay, next one we're looking at. A is not a subset of C. Since it has that line through it, that means is not a subset. So let's look at A. A has the elements 2, 4, 6, 8, 10, 12. And in order for that to be a subset of C, all of those would have to be in C, which is impossible because C only has 3 elements. So A is definitely not a subset of C. So therefore that is true. And then last one here, B is not a subset of C. So we have 4 elements in B. So there's no way B could be a subset of C because there's only 3 elements in C. So that is also true. It's not a subset. Okay, so number 5 says C has exactly 6 subsets. So let's look at set C. So set C is the elements 4, 10, and 12 are in set C. So let's try and think of as many subsets as we can. One subset of C would be the set with 4. We also could just have a set of 10 would be a subset of C. Another subset of C would be the set of 12. Another one could be 4 and 10. Oops. Another one could be 4 and 12. Another subset could be 10 and 12. And we could also have the empty set is always a subset of any set. So let's count. Oh yeah, and also we could have 4, 10, and 12. That's a subset of that because all those elements are in 4, 10, and 12. So let's count how many of those are. 1, 2, 3, 4, 5, 6, 7, 8. So we'd actually have 8 subsets, not 6. So that is false. But the thing is, if we're asked for exactly how many subsets something has, we don't want to count it out like that every single time. So there's a shortcut. The shortcut is you take 2 and you raise it to the number of elements. So how many elements are in C? There's 1, 2, 3 elements. So we do 2 to the 3rd power. That will tell us how many subsets there are. 2 to the 3rd means 2 times 2 times 2, which is 8. So we know it's false because there are 8 subsets, and we just found that to the right. Okay, taking a look at the next one. A has exactly 64 subsets. So we don't want to count out all those subsets because that'll take forever. So we're going to use the shortcut. We just do 2 to whatever power the number of elements are in A. So how many elements are there in A? There's 1, 2, 3, 4, 5, 6. So we do 2 to the 6th power. Feel free to use a calculator there. So 2 to the 6th power does equal 64. So therefore A does have exactly 64 subsets. That is true. So if you were given a problem like that, we would expect you to do the shortcut 2 to the number of elements as the exponent and figure out that rather than counting them all out. Okay, so what are Venn diagrams? So Venn diagrams are a way to graphically, and sorry, I ran out of room because my subsets took up some of that room, represent data and set operations. So an example would be a Venn diagram. We could have two circles inside like a rectangle, and they have an overlap region, which means what they have in common. And a lot of times we'll just call the circles, one of them A, the other B, and then all of the stuff that's not in A or B but it is in the rectangle, that's what we call the universal set, which represents by U. It's typically like a U with two lines like this. So that means everything in the whole rectangle. Okay, so now some more new symbols. The U right here means union. And what a union does, it joins the sets, also known as OR. If you see the word OR, that means the same thing. We're going to join the sets together. The upside down U means intersection. And intersection means the elements that they have in common. Also represented by the word and. Sometimes you'll hear people say the intersection is the overlap region. It's what's in both sets, so it's what they have in common. And the no solution kind of symbol, we talked about how that meant empty set earlier. It also means disjoint, which in set theory means that they have nothing in common. Okay, so feel free to pause the video at any time if you need more time to write something down. But now I'm going to shade each set here. So if I was going to shade A, generally the one on the left is A. So if I wanted to shade this, that would be this entire circle. That's A. If I was going to shade B, we're going to make that one the right circle here. That would be this whole circle. And it's kind of nice to do this on Notability, so you can just use the highlighter to shade. The next one says A, and it has that U symbol, B. That U symbol means union, so we're joining the two sets together. If you're joining A and B together, we're going to shade both circles. We're joining them together. And A and then the upside down UB means A intersection with B, and it's what they have in common. What they have in common is the middle. Okay, so those are your new symbols represented in Venn diagrams. Okay, so now let's look at some true or false here. So we have the set of 1, 5, 9, 11, and it's upside down U, so that means intersection with 2, 4, 5, 7. So what this means is we're looking for what they have in common. So is the only elements that they have in common 5 and 7? Well, they have a 5 in common, Do they have a 7 in common? No, because this one has a 7, but this set does not have a 7, so therefore that is a false statement. If we were asked what the real intersection is, it would only be the element 5, because that's all they have in common. For number 2, we now have the U symbol in between, which means union. So the set of 0, 2, 4, 6, union 1, 3, 5, 7. So that means we're joining the two sets together. So basically what we're doing is we're writing down all of the elements. So let's make sure we have all of those written down. Do we have 0? Yes. 2? Yep. 4? Yes. 6? Yep. And union means join them together, so we should have 1, 3, 5, and 7 also. We have 1, we have 3, we have 5, and we have 7. So that is a true statement. That is the union of those two sets. We join them together, all their elements. Okay, next one. We have the set of 1, 2, 3, union empty set. So we are joining the set 1, 2, 3 with nothing. If we're joining the set 1, 2, 3 with nothing, we should still have 1, 2, 3 if we're joining it with nothing. So this is a false statement. If we are really joining 1, 2, 3 with nothing, we still should have 1, 2, 3. And in number 4 here, we have the set of 1, 2, 3 again, and now it's an upside down U, which means intersection. It means what they have in common. So what do the sets 1, 2, 3 and nothing have in common? They have nothing in common if one of them's nothing, so that's actually true. So be really careful if it says union or intersection. Union means you join the two sets together and write down all their elements. If anything repeats, you don't have to write it again. For example, if they both had the number 1 in their sets, you'd only have to write that once. And if there was intersection, you're just looking for what they have in common. Okay, moving forward here, now we have a new term, complement. And what complement means is for every set A, the complement is the set of all elements of the universal set that are not in A. And it's expressed with the symbol A prime. It's A and it has like a little 1 as the exponent. That means A complement. Or A with this little hat. That also means A complement. So to kind of shorten that up, what a complement is, it's every number or every element, whatever's in your set, that's in the universal set but is not in that specific set. And you'll see with the next example. Okay, so now we're given a universal set here. So it's 1 through 10, all those integers. We're given another set A, which is 2, 4, 6, and 8, and 10. And we're also given a set B, which is 4, 5, 6, 7. Okay, first problem we want to do with this is we want to find the union between A and B. So remember, union means you're joining the two sets together. So we're joining A and B together. So let's make sure we have all the elements. So we have 2, we have 4, 6, 8, 10. And let's add any elements that we're missing. We already have 4, so I don't need to write that again. We already have 6, but I definitely need to write 5 and 7. Generally, you'll see people write those in numerical order, but the order does not matter. So that's perfectly fine. Remember, you don't have to rewrite them if they're the same number. Okay, for number 2, let's find the intersection between A and B. So that's the upside down U. Intersection means what they have in common. So what do A and B have in common? They both have a 4. They also both have a 6. And that's the only 2 things they have in common, so that's it. Make sure you put them in a set bracket. So for number 3, we want to find A complement. So that's that 1 as the exponent. That means complement. So what A complement means is we're looking for everything that's in the universal set that's not in A. So we're looking for what are numbers in that set U that are not in A. Well, 1 is not in A. 3 is also not in A. 5 is not in A. 7's not in A. And 9's not in A. So all those odd numbers. So that would be A complement right there. Okay, number 4. Let's look for B complement. I'm going to write it the other way with the little line above it. That means B complement. So we're looking for everything that's in our universal set, the top one, that's not in B. So we don't have 1, we don't have 2 in B, we don't have 3 in B. We have 4, 5, 6, and 7. We don't have 8, 9, and 10. We're looking for everything that's in U that's not in B. So that would be 1, 2, 3, 8, 9, 10. Okay, looking at our next one. Now this is what we have is a 2-step problem here. But the nice thing is we already know what A complement is. We already found it. It was right here. We're looking for the intersection between A complement and B. So the intersection between those would mean what they have in common. So I already circled A complement. Let's look at B. And we're looking for what do those have in common. So looks like they don't have a 1 in common. They don't have a 3 in common. They both have a 5. They also both have a 7. But that's all they have in common. So that is our answer. So remember, intersection means what they have in common. Okay, next problem here. We have A complement, and we want to find the union with B. So we're joining A complement and B together. So A complement is this one. We already just looked at that. And we're going to join it with B. So if we're joining it together, we're just writing down all their elements, not what they have in common, because this is union. So join them together. We have 1, 3. We don't have 2. We have 4. We have 5. Looks like we have a 6 in B. We have 7 in both, and we have a 9 in A complement. So there's all our elements. Okay, now looking at number 7. We have A union B, and it's all in the complement. So when you have these problems, what you're going to do is you're going to first look what's in parentheses and do that first. So we're going to do A union B. The nice thing is We already found A union B. It was up top here. If you didn't, you'd have to find it again. You'd have to join sets A and B together. But if we just copy number 1, we already found it was 2, 4, 6, 8, 10, 5, and 7 when we join those sets together. So that saves us time. But now what we're doing is we're trying to find the complement of that. What that means is we're trying to find everything that's in our universal set that's not in what we just wrote down. So we know we have 1 in the universal set, and that's not in the part we just wrote down, so we can write that. It looks like 3 is also not in A union B, but it's in the universal set. And also the number 9 is too. So that's our answer right there. The only things that are in our universal set that aren't in A union B are 1, 3, and 9. Therefore, that's the complement. Okay, and these last two problems get kind of long here. But you always do what's in the parentheses first, just like when you're solving equations. So A intersection with B complement, and that's in a union with A complement. Okay, so the first thing we're going to do is we're going to find this. A intersection with B complement. What I like to do is, especially when you're doing these long problems and you didn't already have all those problems before, let's list what A is and what B complement is to help us out. So set A, if we go back up top, that was 2, 4, 6, 8, 10. And B complements everything that's in the universal set that's not in B. So if we look back up top, B was 4, 5, 6, 7. So everything that's in U that's not in B would be 1, 2, 3. 4, 5, 6, 7 were in B. So then we'd have 8, 9, 10. Everything that's in U that's not in B. And we could take a look at our B complement and make sure that it was those 6 terms, 1, 2, 3, 8, 9, 10, 1, 2, 3, 8, 9, 10, yes. So now what we're trying to do is we're trying to find the intersection, since it's an upside down U between those. So what do they have in common? They both have a 2, they both have an 8, and they both have a 10. So what they have in common here is 2, 8, and 10. So I'm going to go over to the left here. The underlined portion we found that as 2, 8, and 10. But we still have to take the union with A complement. So let's write down A complement over here. So everything that's in the universal set that's not in A, we already found it was 1, 3, 5, 7, 9. So I'm going to bring that down here. Okay, and I'm just going to write it over here so we can compare them. And we're looking for the union between these two. So if we're looking for the union, we're looking to join the two sets together. So if we join all their elements together and we put them in numerical order, we have 1, 2, 3, 5, 7, 8, 9, and 10. And that's our final answer. Okay, and then last problem here, number 9. We have, in parentheses, A intersection with B complement. And that's in an intersection with A complement. It's nice that we have all these right here so we can just use those again. So I'm going to write I'm not going to write those sets down again just because they're right above it. But what we're trying to do is we're trying to now find the intersection between A and B complement, which means what do those two have in common? So if we look at A and B complement, what do they have in common? They both have a 2, they both have an 8, and they both have a 10. So we'd have 2, 8, and 10 in our set. And now we're trying to find the intersection with A complement. A complement's right above, so we can just copy that down. 1, 3, 5, 7, 9. That's there. So now let's find the intersection between these two. It means what do they have in common? It looks like they both don't have a 2. They both don't have a 1. They both don't have an 8. They both don't have a 10. They don't have anything in common. When that happens, and that'll happen sometimes, you just put the no solution symbol. It means the two sets are disjoint. They don't have anything in common. So that would be our answer. Okay, so feel free to pause this video at any times. I know it's kind of long, but it should help you, especially with today's assignment.